Okay, so good afternoon, everyone. Today we are going to continue from where we stopped last Wednesday. So if you recall, last class, we went through prompting. We had a good understanding of large language models that will help us to understand how best to write our prompts and get the best out of it. Of course, remember the prompts are very important because even as a developer, it is prompts. Prompts are your primary tool of communication with the LLMs and all the other models that we will be communicating with. So anything that you will want to get from your LLM model at the back end, you will use prompt. That is, in fact, think of it this way. A prompt is a programming language for you to program your large language models. So what that means in essence is that we have to learn how to get the best out of our prompts. I'm going to do a quick recap just for the benefit of maybe those who were not in the last class. I'm not going to talk about what a large language model is, but I'm going to talk about the prompting skills, what matters. So the first thing that you understand when you realize how prompts work is that prompts, large language models rather, are they are predictors. They are predictors of the next word based on the whole, list of previous words that you've given to it. So it's not really intelligent in that sense, even though by the time you look at all the data it has been trained on, it will exhibit intelligence, right? So it means that effectively, a large language model predicts the next word. So when you understand that, what you then realize is that it's predicting patterns it has seen in its training data. So it's not really telling you the truth. It's telling you what it has learned from its training data. So it is important to then realize that if the training data is wrong, then what it will tell you will be wrong, right? And that's what we call bias. So if a human being, if you give it data that has biases, right, then it will learn those biases and it will regurgitate and give you back those biases as well. So in order for you to get the best out of it, because it's predicting patterns, you have to give it a very clear and precise context. That is, you have to tell it very clearly what you want. You are not going to get much out of it if you are being very generic or very ambiguous. You have to be specific and detailed as much as possible. So that's the first thing. The second thing is, yes, you have to give it context. So in your prompt, you need to give it all the background. You know, you are a senior backend engineer, that gives it a background to start from, right? Right, a fast API app and so on. So that's the second thing, right? I won't dwell much on this because we already have them in the previous video and in the previous class. The other thing is it has this tendency to imitate. So it has a strength in imitation, and you can leverage this and exploit it to the best of your own advantage, right? So you can always tell it in your prompt, follow this pattern. If you even wanted, like we're talking about writing test coverage, right? If you want to write test coverage, you could actually tell it, okay, when you write a test coverage, follow these templates that I already have. This is very powerful, and we're going to see how we'll exploit that later on when we start building our own products or apps or tools using these LLMs. The fourth and most important thing is there's what we call a context window. There's a limit to the amount of information you can put into an LLM at once, at a go. That is what we call the context window. And depending on the model size and all of that, it could be as much as, some of them can get up to 300 and something thousand tokens or 16,000 tokens, or even smaller ones that are maybe just 1,000 tokens. So this doesn't mean that you cannot give it multiple data in sequence. But you see, at that point in time when you're sending it chat and the chat history and all of that, right, you are limited. And once you send new stuff, it is new context. It's starting afresh. It doesn't have any memory of what you had conversed with it or whatever interaction you had with it. So the context, that's why it's called context window. The context of your conversation, everything must be inside that context window, within the size of that context window. Uh, Outside of that, it's a new conversation. So it doesn't know anything about, that. So you have to manage your context window. And the only way, one of the ways to do this is you have to rework your prompts, summarize long inputs before you prompt. um, Sometimes what we call prompt chaining, which we talk about, is split your prompt into smaller um, units, smaller task. When it finishes one task, then you can take the output from that, summarize it, and send it again as a second prompt, and do that, consecutively until you get your output. So that's what you learn from knowing that. Yes, you can chain prompts. We just talked about that. So we have what we call prompt chaining. We're going to do a lot of prompt chaining today. And then, yeah, you also can use what we call temperature to introduce some variance, some, differences in the response, or so that you can search wider for answers instead of just always giving you the same thing, right? But the temperature has to be controlled. If it is too much, it can give you results you don't like, apart from the response itself, but the consistency of the response. In coding task, you always like to have a bit of consistency, because if, for example, you ask it to refactor your code or to generate code to do something for you in one way, right? And then you want to adjust, you tweak a few things in the prompt. You don't want it to regenerate a whole other different approach of doing the same thing. You still want it to regenerate the same code, but adjust a few things that you wanted. Maybe, for example, you want to change the variable name or something, or you want to change a single implementation of a for loop. And instead of giving you back the exact same code, but just changing one or two of those things that you said, it will generate a whole new thing, right? So in such situations, that's probably because the temperature is too high. So you want to be able to adjust that. So temperature is not something you will see on the UI, on the user interface. Like if you are typing prompts on ChatGPT, that is something that that's a developer thing that you send as part of the payload that you are sending. So those are some of the things to take note of. And then we talked about prompt engineering, and we looked at the key tips for a developer. One, always be specific, avoid vague requests, avoid ambiguous requests, always be very precise, very clear on what you want the LLM to generate for you. Set the role, always guide the tone by specifying the role and the expertise. That actually helps, because if you say you are a DevOps senior engineer, it's going to be different from you're a DevOps junior engineer. The code might actually be different. So that is very important. Iterate, refine, and rerun. So if you do a prompt and it doesn't give you what you want, you can fine tune the prompt, run it again, and you keep doing that, asking for improvements. Decompose the task. That is prompt chaining, basically. If the task is complex, break it down into smaller steps and send each step as a separate prompt, so that the LLM will be better able to do it, because a smaller task, it doesn't have to carry so much information. Use delimiters in your prompt. It helps. Commas, question marks, using the code block delimiter, using the quote block delimiters. This help to give it context, additional context on what you are doing. So today we are going to do a bunch of things. I did ask everyone to give me examples of a really complex task that we can break down, and then use prompt chaining techniques to, break it down. A bunch of people gave me some things, but I think it probably was too much, right? Um, so we are going to do something, right? And we're going to do a very specific task. So if you look at this, right, you have different kinds of prompts that we can use. code generation prompts, which again always starts by setting the tone, the context, the level, the background. Then you give the task, right? Like one other thing we mentioned is even within a single prompt, you can still specify steps in the single prompt. That's not prompt chaining, but you're still breaking it down. It helps the LLM to be able to generate a better output for you. Refactor your prompts as you need. Then this is these are prompts for refactoring, right? And then these are prompts for testing, and then prompts for debugging and prompts for documentation. And then finally, prompts for API generation. So I want us to use these prompting techniques without writing any code yet. We are going to use um, maybe one of the tools that we have and see how we can build a, a code review tool. So you have a prompt chain here. You start with the input, which is a diff from a PR. So I'm actually going to just create a random diff from a PR, and then we will now chain these prompts, right? And then when we chain these prompts, then we'll use a visual tool first to see what we get, right? And then after that, um, we will then put it in code and write it in code. So that's this. We'll start with this task, and then we'll go into the exercises, which basically is going to be the same thing, right? So, but that one is for generation. So let's start with this one: code review plus documentation plus test cases. Okay, so I'm going to do this by using one of the visual tools that we looked at. Okay, so let's use ChainForge. So we have chainforge.ai/play. So ChainForge is an open source tool that allows us to play around with prompt chains. I'm going to, so this is an existing, you know, thing that they have. I'm actually going to just edit this. So I'll take this as an input. This input, I will just load in a diff. So I'm going to create a diff quickly just by let's first of all generate code. So I will use Gemini. So let's say I have a simple piece of code which I'll pick from here. generate code for bubble sort algorithm. So while that's going on, I just want to get a div, right? So I have a bubble sort algorithm. Um, generate a div um, with some improvements in standard div patch format. It doesn't really matter if the div is, you know, so now it's able to, first of all, generate the bubble sort algorithm, which you can see here. I'm not really going to look at this, right? But I assume it's a legit bubble sort algorithm. Then I now ask it to generate a patch file. So here's a patch file that it it generates. Interestingly, what it considers as improvement. If you look at a patch file in standard diff format, right? This unified diff format, for those of us who have used a GitHub or done a Git diff, you always see something like this, right? The minus means something that's removed, and it's normally in red. The plus means something that is added, and it's normally in green. So basically, what this diff is doing is that it is adding the type, it's adding typing information here. It's adding the type to the function definition and the return type as well. And then it's adding documentation. So that's like very good diff file. Okay, so I want to now copy this and use it as the input for my thing. So I'll put it in here. So it's now in here, right? This div that has been generated. And um, so this is now the input. So let's run this. Let's go back to what we are trying to do, which is okay. So this is a pull request div basically. So this is an example of a request div which Gemini has generated for me. Then summarize the code changes. So the step one, summarize code changes. I will have a prompt node that will do that. Okay, so summarize. So I want to change the name of this thing, right? It's a node. Well, we'll just leave it. I could also um well the name is not book though, but I'll leave it as it is. Okay, well, I'll just leave this as it is. We should be able to modify that for lack of time. So the prompt we want is summarize code changes. Summarize the code changes in the div file, in the div below. Then I would put this in markup. I always like doing this. Okay. We see our Falcon and ChatGPT set up. So if I run this will probably fail because I did not specify a template variable. Okay. Okay. So Okay, so I need to add an OpenAI API key. So I'll remove this, I'm going to add a new um, I'm going to add a new one. Let me use open. Hmm. I have okay, maybe I will use Gemini Flash. I'll need to get the API key for it. So API key. This is configuration. Okay. I was going to the wrong place. So I'm going to get the Gemini API key, which I have around here somewhere. Okay, so summarize. So this is a prompt now because I have passed this in as from the input text node. I've passed this in. I've added my prompt. Summarize the code change in the div below. So maximum retries rate Google Gemini is returning. Okay. Let me try this again. I don't know if this allows me to access. Yeah, okay. Maybe Flash is not free. So flashlights. I have used Gemini before and I did not have this. Okay. All right. So flashlight works. Okay. So that's what I needed to use. Okay, so flashlight works and the output from it goes into this text node. So if you look at this text node, the text node gives you the provided div shows changes to the bubble sorts.py file. The primary changes are this. So it explains the changes, type hinting and docstring, docstring content and all of that. So you have made one prompt in your prompt chain. This is just to allow us to bring in the input. This is the actual prompt. This is just for us to look at the output from it. Now, the next thing is suggest improvements. Okay. So that we can still do as, okay, maybe we can, let me add another prompt node now so I can add a prompt node. So I add this prompt node, suggest improvements to the code changes in the div below. So of course, by now we have seen that you can just by putting stuff in the braces, right? It will immediately be recognized as a variable which you can attach. So I could decide to attach this, the output. I could attach this to the output from here. That's one way I could do it. So the text node is allowing me to see the response, but I don't need to connect to the text node. I just connect this. But then it's not really it's the diff I want to do improvement. So I could also do another inspection node. So let me add another inspection node here. And then just link the output from here to that one. Then I can run this prompt. Okay. Open AI. So I'm going to remove this. I'll still use Gemini Flashlight 2.5. Okay. So you can now see it has suggested improvements here. So this is the diff that it gets, and then this is a response. The provided diff shows a good start to improving the bubble sort function by adding a docstring and typings. Here was some suggestions. So now if you were reviewing this PR, so let's say the PR is this diff, and you ask it to review this PR, then Gemini will basically just give you suggestions of things that should be improved in this. Now, let me manually introduce, even though I don't usually manually, um, you know, um, modify a patch file, but you could actually manually modify a patch file. So I could add something and maybe add something that is wrong syntax. And I can run this again. It's going to tell me about that wrong syntax that I just added. So you see, it has already detected it. The problematic line, wrong syntax here. This comment is not part of the actual code change. It seems to be a placeholder or a note left by the person who made the change, indicating a syntax error they encountered or were aware of. The div doesn't show the incorrect syntax, but it's implied that this docstring structure is flawed. Okay, so well, I think the reason is that I put something here that's not really part of the div. Okay, div has a structure, so you really can just add stuff the way you like. If you look at this, let me put it here. It says from line 1 to 5 on the minus part and line 1 to 17 on the plus side. So let me increase it to 18. So so Gemini even knows about div structure. Okay, so it changes. The syntax error is almost certainly at the line. So now it recognizes it as a standard div, right? But it is now saying there's a critical error pointed out, wrong syntax here. This indicates that the code immediately following the doctrine is causing a syntax error. So sometimes it may not be very useful information. Okay, so that's the second step. Now the third step is, okay, that's suggesting improvements. Generate docstrings for modified functions. So we'd add that. I need a kind of a diff that has this. Write test cases for new functions, produce a markdown summary report. Now I can do this. Let me say I use the original function, right, instead of the diff. It's entirely possible for me to achieve that. Okay, so this is a very good example of okay, let me make a new text string. Oh, not this. Let me make a new text string. Text field. So I'm going to paste the code. By the way, I'm just using text field. If your code is a lot, it would make more sense to use something else, files, to load files. Or if you have visual image data, you can use this. Okay, so yeah, let's go back to this. So I'm going to remove this, and I'm also going to remove this. So instead, I will connect this to this. So this, I can now say to the code. So the prompt has to change because now it's no more a diff, it's an actual code. So just improvement to the code snippet below, right? Okay. So if I write this prompt, I'm going to get a different thing here. So the provided bubble sort function is standard and reasonably optimized implementation. Here are some suggested. So it has even suggested doc strings and type hinting, clarity of loop bounds, alternative to sentinel value. Okay. So now what we could do is we could chain this, right? So how do we chain this? You can see that I have the input, I have the output here. I can create another node, prompt node. And then in this prompt node, I can add a new prompt. Suggests implement the improvements suggested in the response below, right? And then the response, I can use a code kind of thing, and I can just say improvements, right? To the code snippet below. And then I can use this for code snippet. Okay. So again, still use Gemini. Gemini flashlight. Okay. So for me to get the improvements are actually coming from here. So this is a good example of where I have chained it, right? The output from this prompt, I have chained it as input into this prompt. But in the same way, I still need a snippet, so I'll still chain it to this, right? And then let me create another inspection node so that I can see what's coming out from there. So with this, I would run this. So it now suggests improvements based on the output from this onto this. So you will see it implements that. Then the next thing would be, okay, the docstring and modify function has already been done. I can now do another one to write test case, right? So in order not to have my context window blowing out of proportion, because already I have a problem here for your information. If you're not really paying attention, but if you were paying attention, you see that in this particular prompt, I have added the response from this, which can be pretty long, with the original snippet, which can also be pretty long. So I have to start, kind of paying attention to the size of the prompt. It's getting bigger. So you have to watch the context window. But I now have a modified code snippet here. So I can add another prompt node here. And in this prompt node, the prompt I would say is the last one that we have in this task, which is write test case for new functions. Okay, so write a write test cases. Let me just make this yeah, write test cases. Test cases is a bit um ambiguous, but no problem for the new function in the snippet. Well, it's not really a new function, right? So we can say for the bubble sort function, for the function in the snippet below. So again, we'll have this, again, use delimiters. So I have a snippet. I'm still going to take it from what came out from here. So it will be smaller. Then I'll still add an inspect node to allow me to view. The purpose of inspect node is really just to allow me to view what's going on inside. Okay. And then I can run, okay, I need to change this and add Gemini flashlight. And then I run this. So you will see we now have test coverage here. If I have a whole class test bubble sort, right? And we have the test coverage in Python here. So effectively, you can even look at it, the tests are making sense, right? Yeah, tests are making sense. So we could have done all of this in one prompt, right? But we decided to split it. This is, to be honest with you, everything I did with these 3 or 4 or 5 prompts, I could have done in one prompt, but this is just to demo it. There will be some tasks that will be so much. If you put in one prompt, the LLM may not be able to handle it because of the size of the context window. So if I want to run all of this, right? Something changed. Downstream results might be invalidated. Okay, so something changed. This is just telling me, okay, I've disconnected something. So, but this is not part of it anymore. This is just this is a different thing. So you have all of this and you have the full chain. So this is how you can play around with your, you know, with your chains, continue to fine tune it until it is good enough. Then when it is good enough, the next thing is to write your code that would chain this and give you the response. So we're going to do that also. So I already had something that I started, so I'm going to bring that in. The whole idea is I I kind of already wrote it in Colab. I'm going to bring it in here. Okay. So I have written a client. Note that I used Gemini then. Maybe I might still decide to use Gemini now. So, but I'm going to do my set of prompts and then I'm basically going to run it. So the AI client is my helper function. If you use OpenAI client, you probably don't need to do, all of this, right? But because I had started it, so I just continue. So I'm going to create a new file, call it .env, and I'm going to put my API key there. So I already have the API key. Let me see if I can get it back. So the API key is in this settings area. So this is the API key that I got from Gemini. And I'll also put it in here. Okay. So first of all, I want to test my API key reader with this. Okay. So basically writing a function that reads environment variables and puts it into um okay. Um okay, environment, yeah, so bars. Okay, so if yes, I could just do this straight up this way. So return yeah, okay. So if I pass in a variable, it gives me that. If I don't pass in a variable, it gives me so this is just there are other tools that do this, so probably don't need to do it yourself. Okay, so I'm not going to use open router, I'm going to use Gemini, and I'm just going to call, well, okay, let me use open router because I already have open router set up here. Um, I'm going to create a new open router key. Okay, I have to get an open router key, so give me a few minutes, few seconds. Okay, so I'll put it in my .m file as well. Okay, so I have open router key, I have Gemini key. So now, so I have a client, I have a get API key function, and so let's do the prompt chaining now. So this is the open router API, this is the open router key, get API key. So and then this is open router, um, which is basically an open router client that I have created. Um, so open router key is okay. So now let's set up the prompt chain. So the prompt chain, um, we'll just do it manually, right? We could have done it in a loop or something, but let's just do it one at a time. Set up the prompt chain. So the first is, maybe we can refactor it after. So the first one is the input, right? Um, the input, which is the code to be reviewed. So we can just put this in a here doc or here doc. Probably keep forgetting how to do here docs in Python. Okay, let's do it this way. Okay, so the code, bubble sort code, I'm going to copy this and I'm going to put it in here. So that's the code. And so that's step one. Then the prompt one. So our prompt one was suggest improvements to the code in the snippet below. And some of this, so eventually, if we want to build a system around this, we have to make it so we can I could do this. Um, good. Okay. So this is the first prompt. Then we can run it. So I'll run the open router. That call with the prompt one. Then we get the response. So yep. Okay, so let's run all of this. So we have our import, we have our AI client, we have our API key, and then we run this. So this is actually calling the open router with Minimax. Let me close this so that we can see more things at once. So we have Minimax M2 free, which is free. So that runs and it gives me this. Here are several improvements for your bubble sort implementation. So we have essentially the same thing that we got here, right? With this prompt. They provided is a standard and reasonably optimized. Now this one says here are several improvements. So we get this response. One of the things that we'll have to learn is a lot of these LLMs, they will return their response in Markdown. I think I mentioned this before. So the Markdown, we will have to figure out a way to make it readable. Okay, so for now, it's not very readable. We'll come to that. So we can take this response and chain it into the next prompt. So basically, if you were doing it manually, right, I would now do a second prompt. I would now say, okay, prompt 2 equals, prompt 2 was what we got here. Prompt 2 was implement the improvements, right? So we now have two things. Let me just copy this and I'll put it here with an F string. So to handle, right? So improvements, let's call this improvements, right? So improvements is what we get from here. Then snippet is still what we call code. Maybe I should change it to snippet just to maintain consistency. Okay, so this is snippet. Okay, so this runs, after this is done, we will now run this one. Same way, we'll call it with prompt 2. So you can see prompt 2 now has the prompt, and then we've injected the improvement, the response that comes from here, and we've also injected. So we form a new prompt and we chain that one and make another API call to the with a new prompt, and we get a response, and we'll now see how that will look like. So let's run this now. So again, this is an API call. I'm going to add a new code block for the third part of it, which is write test case. So while that is running, I'm going to do this part. So you can see here's improved code with all the suggested enhancements. You can see that already. Then prompt 3, another F format string. I'm going to paste this, and well, it completes it for me. So write test cases for the function in the snippet below. So this time it's not going to be snippet, it's going to be the improved code. So it's improved code. And that becomes from 3, and we also chain from 3 in. And we're going to get the response as well. So this is basically prompt chain. This is manual prompt chaining. Now, this thing we call LangChain would do this for us in a structured manner. So when we get to LangChain, we're going to use it and a bunch of other tools. So you can then plan, your prompt chains, how you want to inject stuff into it and all of that. So let's see what comes out of this, right? So it does this and you have this. Now I'm going to figure out how we can print Markdown directly in a Jupyter notebook, and I'll share that with everyone. So that is, okay, we can say produce a Markdown summary report. Remember, you have to maintain the history. If I run a prompt now with a new prompt, for example, let's do this. I didn't give it the historical context, and I just say something like open router dot call with prompt. And let's say in the prompt, what I put is this, produce a Markdown summary report. Okay. The prompt is produce a Markdown summary report. You will be very interested. I want to try this out and see because I don't give it any previous context. I'm just saying produce a Markdown summary report. It doesn't have historical context. It doesn't know anything. This is the entire input that goes into the context window. It's going to come back and it's going to give me gibberish, basically. You can see. It has absolutely nothing to do with what we are doing. So, this is why you always have to concatenate all the historical, the prompts, that were done in the past and everything to be able to get this outcome. So this is just a simple demo of what we mean. You take prompts, you try it out with a visual tool like ChainForge, and then after that, you then write your code around it. So with this, you have automated the process. Now, I think there were a few questions, or I asked for, people to come up with ideas, right, of how we, a complex task that we can break down and maybe use chaining to do. I didn't really get a lot of good answers. So does anybody have a suggestion? Let's see if we can work that. Any ideas? Type it in the chat. Nearest node. Nearest node. Okay, I thought that was an idea. I need ideas. Are there any questions? Questions? Ask questions that we can clarify. This is time for you to ask questions. Yes, go ahead.
Okay, sir. Thank you, sir. Please, I want to know, how do you insert your API keys in this chain forge? Like, how do you put the API keys?
Okay. So you can see my screen. If you see my mouse, you see this gear
Settings.
icon at the top right.
Okay,
You
sir.
see API keys. So I was actually looking for it before because I was thinking it would be in each place here, but it wasn't here. So, but it's up here. So here you put all, and I think they are different. You have OpenAI, you have OpenAI based URL, Anthropic, Google DeepSeek, Hugging Face. So we could even, like, if you want to use Open Router here, you can put your Open Router API key and then use Open Router based URL here. So that means we can still achieve the same thing with Open Router. Anthropic, same thing. Google has a fixed endpoint. DeepSeek, Hugging Face together. AWS also has. So they made a lot of provisions for all the different providers here.
Sorry, sir, I did not get you. You said we can put open routers on in any of those places.
No, for Open Router and Open AI, Open Router uses Open AI protocol, right?
Okay.
It uses the same endpoints and all of that. So for Open Router, because you use the Open AI protocol, you can use this in this Open AI based URL. You put the Open Router based URL, okay?
Okay, sir.
And then you
Yes,
put
sir.
an Open Router. So that allows you to access Open Router. But if you don't
Okay.
put it, it will use the default one, which is OpenAI's base URL.
Okay, sir. Okay, thank you.
Yeah. All right. Any other question? So again, just let me summarize. What we are trying to achieve is how you can use these visual tools, this ChainForge being one of them, to just try out your, prompt chain before you go and start writing code around it. Even though with LangChain, things like LangChain, it's probably easy to you to write those, whatever chain of prompts you want to do. So, okay, you could still do that, but this is to just do it without having to set up a programming environment first. That's the benefit of this. And that's what I was trying to demonstrate here. Okay, are there any other questions? We will then try to do a real world um, PR reviewing, you know, um, a PR reviewing prompt chain, basically. Okay, so there's some interesting. I am told that some of this markdown we can actually use IPython to do that. So let me try that out and see how good it is. So you import from IPython.display. Uh, this is for LaTeX. LaTeX is for mathematical stuff. So here, uh, the markdown I want to display is the test cases. Let me see how that looks like. Right. So this is very nice. This is what I was looking for. Um, so this is what I was saying, that this is the last one. Okay, let me make this. Let me Yeah, I think it's good to just make this into a function. Oh well, it's okay. Um, so the benefit of using this markdown approach is that we are going to see better code. It's going to basically write these things out better than what we had before. So I'm going to bring this to the top. Then I'm going to rerun the entire thing. Yeah, improvements, display markdown improvements. Okay, now let me run everything. Do we understand what we are doing here? If anybody has any question, let me know, because this is now very interesting. So this is the first, these are just, these ones are both are functions I wrote, what you may call helper functions, just to help me to be able to do what I need to do. This one creates an AI client that helps to access and run prompts on the AI, right? Okay, some people are suggesting, can we do it with JavaScript? Okay, maybe that's the next thing I'll do. It's going to be a learning journey for me as well, so that will be interesting. We'll see how we can do it. I'll do the same thing with JavaScript, and um, unfortunately, JavaScript only has CodePen. So how do we inject it? Well, we will see how we can inject it into the DOM. Okay, so the first one is this one, and I've been able to figure out how to make the markdown. So now it actually prints it properly, right? Instead of giving you all the source code of the markdown, it actually prints it. So you can see the improved code snippet, right? The first query was to So here's an improved version. This is a response where it tells me here's an improved version of the code with suggestions, blah, blah, blah. And it actually gives its improved version. It adds the um, doc block and the list and all of that and all of this, right? So it's already done the solution anyway. But I was just trying to, show you how to do prompt chaining. That was the main thing. Key improvements, blah, 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 blah. The second prompt is implement the improvement suggesting a response below. So this is the response, right? Key improvements, it does this. And well, it's interesting that the testing suggestions, then this is the third prompt that says write test cases. So the prompt was write test cases. And this is the original function, the improved version of it. And then this is the test cases that it writes. Okay. So this is like what you would have gotten if you were writing this in maybe VS Code or something. Or if your prompt was in VS Code, it would directly modify your code and give you all of this. So these are additional tests. And then the last part is where I said produce a markdown summary report. This is where I was trying to show you that this is totally, it's even asking what, because I didn't put any context here, right? So it's just basically blank and telling you, wait, you know, what are you asking me? Or what are you asking me to do? But if we had, you know, added all the previous prompts as a context, right? Either as a system prompt or as previous, concatenate it to the um, user prompt as previous, conversation. It wouldn't ask all of this, it will just be able to generate it. Okay. All right. Is there still a question? Okay, if there is no other question, let's see if we can do this with JavaScript. So let me use CodeCamp.io. So I'm just going to start coding. If there's a better tool than this, then please let me know. We are not going to do any CSS, so I'm basically just going to, remove the CSS. So we'll just do basic HTML, head, title, is prompt chaining. Oh wow. Then you have the body. So I'm going to create something here, a div. I'm going to give it an ID. Um, yeah, body text. So this is where I will chat response. So this is where I'll just put the chat response. I'll just keep appending it here to the inner HTML. I don't know why it's asking me to save. Okay, so this is the whole HTML. Save, hold up. I don't have an account, so I probably do, but see, I'm going to lose all of this. So let's leave it. Okay, so in the JavaScript side of things, I'm going to write a few functions. So let's see if we can write. Now, this is where we'll have a bit of challenge, but I'll write my own AI client in JavaScript, just like what we have done here. Um, I'm just going to make it like very simple. Um, there should probably be a constructor, but let me just call init. Um, okay, I'm going to do this in order to speed things up. I'm going to use LLM to basically translate the Python to JavaScript for me. That's what I do. Um, so that's going to be faster. So that's why I said, you know, we have lost the battle. If you say you're a coder, let me even do it here so we can see it, right? I can use Cloud or Gemini. You can use ChatGPT, Cloud, Gemini, any of them, right? So so I can just say convert this to JavaScript. So if you say that the only skill you have is that you are a coder, you know a particular programming language, you've already lost the battle. So convert this to JavaScript. It's going to give me JavaScript. Well, while it says it's ruminating on it, so I'm actually going to run another one on ChatGPT as well. It's taking longer than usual. Okay, maybe it's a hard problem. So let me meanwhile be writing my own version. Um,
Sir, please, can we try it on ChatGPT?
yes, you can. I've tried it on ChatGPT, by the way. It's also spending time. So while they are
Oh,
busy thinking about it, me, I'll okay, ChatGPT has given me an answer. Cloud is still thinking. Okay, so let me use ChatGPT. So now I was going to just start by myself with this, but okay. This is the constructor, to space indentation, constructor, right? Okay, so endpoint API key default model. So we have that. Then call with prompt, which is an async method. So I don't have to type everything. Okay, call with prompt, system prompt model, no. Headers, content type. So you see, you still have to do your due diligence. That's why I tell people, don't outsource your brain to an AI, right? I still have to check everything. So payload, JSON, stringify, um, model is model. So now we're having model. I don't know where model comes from. Okay, if model is provided here, user one, if not use a default model. Messages, you have the system, role system, content system prompt, role user content prompt. Okay, temperature 0.3. You probably should add temperature here as well. So then we'll have temperature. Okay, so you've stringify the payload. You now call fetch, call the API endpoint, method is post, headers is header, body is a payload. If the response is not okay, it throws new error. If it is okay, data is await response dot JSON. Yeah. So this I think there's a missing bracket. Okay, so we have that. So we've built that. Then now the next thing is, yeah, to get the API key. But I'm not going to try to solve this because I don't know if CodePen has environment variables added. But I do know that if you log in, you can have a file system here where you can add stuff. But let me just put the API key here at once. So we're going to put, what were we using? We're using open router. So use open router. So this is open router API key. Now, so we've created the class. So we can now say client equals new AI client. So we'll pass API endpoint. So let me add that here as well. For open router API endpoint, I'll just take this. So use that. And so we'll call the API client the model, the default model specify is minimax. So where is it? Yeah, minimax M2 free. So we'll have that. So new client API URL API key, then minimax. Let me confirm that API key API endpoint. Let me call it URL. Oh, endpoint. Is that the correct thing? That's not the correct thing. API. It is. Okay, that's correct. API and key. Okay, let's use URL. API URL. API key. Okay, so API URL. So we have a new client now. So we can try out a simple prompt and say, okay, const response equals client dot what is this call with prompts. So tell me something nice. So this is just a test prompt. Then we can console log the response and see what it looks like. Oh, by the way, this is await. Okay. I wonder if await will work inside the CodePen, but let's see how it does. Okay. So if we check console, await is only valid in async functions. Right. Okay, so for us to make this work, we have to make a function, basically. Oh, okay, so let me make a wrapper function. So to make a wrapper function, I can say call with prompt equals
Hello, sir. Line 50, the response is not correct.
And 50.
Yes. An
Oh,
S is missing.
oh yeah, okay. Okay, but I think we have a bigger problem. So let me see how I can make this work in this context. So I have an async function which I will run. Okay, okay. We don't need to do a wait. We'll just do it then, right? Okay, so it's obvious now what to do. So just call it prompt and then do something with it. Response. Right. So this should work. Did I miss something? Yeah, this should be okay now. Still looks like something is missing. Oh, my class AI client. Okay. All right. Are we good? Let's clear. Okay, so let's add a button here. Um, um, you can actually have scripts in head, you can have scripts in the body. Okay, so because I'm just doing plain JavaScript, right? So yeah, we can do that here. I hope this is going to be visible, because if not, then we are in trouble. Okay, so I'm just writing the JavaScript part of this thing. So I now create a button in the page and click here to run, right? So I just create a button. So when I click on this, it should run something. I have on click. Okay, on click, I need to specify the handler, handle click. Okay, right. It's on click, maybe a small C. I can't remember. I've done so much of React. I can't remember JavaScript, plain JavaScript anymore. So I'm just going to do some tests. Yeah, now you see why everybody's doing. Where's the console? Seems my click handler is not coming through. The other thing we could just do is just run this. Of course, if we're using a framework like do I have to import this? Probably do. There you go. Okay, was just wasting time. Right. It was actually working. Yeah. So I get my response. Not because I clicked the button, by the way, the button doesn't work, but because of this other one that gets initiated immediately. So, well, this was just trying to, demo how we can do the same thing with JavaScript, and you can see I've gotten the response. Now, one thing I wanted to do was instead of logging this, I would append it here. So instead of console.log, which we can still do, right? So let's do this, but we can also append it to the elements. So you could do something like document get by element ID, and the element ID is chat response dot inner HTML equals. Okay, let's get it first. So we'll say div element is that, so you can now do div element dot inner HTML plus equals should it be inner HTML, inner text? Oh, it's even like might not even work because this is markdown, right? Response. What did I miss? Oh yeah. Okay, but the div thing didn't work. So it seems I don't really have access to this DOM here. But anyway, oh, it should be get element by ID. Not get by element by get element by ID. Okay. So you can see you get the same thing with JavaScript. You can do message choices, response choices. Let me take this because this is what I used to pull out the actual content. It's response. So you can take this and still put it in your JavaScript, this response. So if I don't want to log everything, you can make it response choices. Choices 0 dot message dot content. So that's a response. And we should get something better. Did I miss something? Yep, I didn't. So here's a gentle little thought to brighten your day. So this is just dumping the response. Okay, and so I hope that helps. CodePen is not really good. Oh yeah, finally this one came through, right? So it's not this that I wanted. It's not the response I wanted to append to the. It's the whole chain. It's the actual content that I wanted to append. So that one is now working. So the only thing that's not working yet is the. Yeah. So this is it. The only thing is, how do I make this into a markdown thing so that I can understand the markdown and interpret it? So that's something to look at. Okay, so that's it for chaining. Let's try this exercise. Now, I would like us to Podium generate data validation function, ask AI to generate doc strings. I think we've just done that. The other example is provide buggy code and use AI to explain. So these are like tasks I would want everyone to kind of do. Now, let's do the big thing. We have 20 minutes to do this. The task at hand is a PR reviewing. We have two things that we will do. AI augmented code documented tool. I think we kind of just did that. This is a mini project I would like everyone to do. And that will be your task, kind of. Build an AI enhanced code reviewer script that summarizes and reviews pull requests, right? We've kind of already done it in a way. Okay. The only thing is I want you to do a bit of research into how can I get pull requests? How can I have access to the pull requests? Let's start with that. Ultimately, we are going to embed it. There are two ways. You can either embed it as an extension in GitHub, or you do it as you know, a code that runs or a script that can run in GitHub as a runner, right? So I want everyone to do this. Do a bit of research. So this is not something now that, oh, I'm just going to write the code. It's not just about the code. It's about how do you even access pull requests. In fact, what I'm looking at is a situation where I make a pull request, and that pull request, this this bot or AI automatically reviews the pull request and gives some feedback. Interestingly enough, you can do this with just a single prompt. You don't need so much. But the only thing is you need to have access to the pull request. Okay. So for those who have not, I hope everyone here has dealt with pull requests, because I'm assuming everyone is a developer. And the pull request, that's how we write code, right? That's how we share code. So if you're having difficulty understanding that, then let me know. Then maybe we can find a way to help. But this is what is going to be a task. So we will start this. Now, what I will do, I'm going to give more instructions because I'll do a bit of research myself. I'm going to give more instructions on how to test your script, right? Or how to test your AI. And I'll tell you how to do that. We'll basically have everyone join an organization on GitHub where you'll be able to run yours, and then we'll take it from there. So that's it. Any questions? Do you want me to still do this in Kotlin? It's because nobody gave me task. Oh, that's why I'm now the one giving you, task. The whole idea was bring your task, right? Bring a complex problem. But we didn't have anybody that had a complex problem for us to solve. But if you still do, then we can use your own. Otherwise, you do my own. Yes, Ginika, go ahead.
Yes, sir. I don't know about the others, so but I don't know why I'm feeling like this pull request something is tough. Like I was hoping if we can start with smaller tasks until we understand the whole thing, and
Yeah,
then
give
we
me
enter
give
the
me an
school.
give me an example now. Give me an example.
I don't know.
If you
You are
don't
the
give me,
instructor.
you do my own. Who is PC? I don't know. PC. Go ahead, but introduce yourself first because your name is not PC. I don't think your name is PC. Go ahead.
Good evening, sir. Hello. Can you hear me, sir?
I can hear you.
Sorry, I just take my LMS. My start is not yet ready. It's still showing 0.
Oh, that's a different question. Don't worry, we are not done with that yet. You were not there at the beginning of this class.
Okay, so thank you.
All right, let me stop the recording now.
Okay, sir. And also, please, is there a new topic for next week, or are we still going on with this one?
So next week, let me show you the topic for next week so we can prep for it. Next week, we are going to basically look at APIs, SDKs that you can use as a developer. So we will start looking at things like using LangChain, right? And then we are going to look at we're going to basically look at what are chains, and looking at LangChain, even though we have it all the way down in week 13, but this was back end, right? So, but I'm going to give you, and then we're going to start talking about vector databases. This course outlook that we have is a bit, we're going to modify this. So I'm going to point that out in the channel. Okay.
And sir, looking at the LMS, you said we'll be discussing LangChain next week. And the LMS is talking about, is it something about the API streaming, caching, the batching
Yeah,
or something? I don't
yeah.
remember.
So that is not really a big deal because streaming is when this LLMs send you back information, they're sending you information as what we call a data stream, right? So just being able to handle the data stream is not a very difficult thing. We're not going to spend the whole of next week doing that. Okay. Hold on, let me get the updated. Let me pause first.